The dummy model in Scikit-Learn. Knowing the importance of dummy model and how helpful it is, Scikit-Learn has a version of dummy model. Scikit-Learn has a dummy predictive model that can be used for comparison with your model. This is called for sanity check, as if your model has a high performance rate, for example, a very high accuracy score, as we did in our previous example, 99%. That's really high. And then you use the dummy model to also solve that problem, and the dummy model provides similar or close performance rate, then that means that your model is not good enough. So this is called sanity check. Dummy classifiers, as in Scikit-Learn, provide a null metric or a null accuracy. This is just a baseline so that you could compare it to your model and its performance. You have to make sure that do not use the dummy predictive model in Scikit-Learn for real problems as a legitimate predictive model, because it is not. It's just for a sanity check. And there is no real logic behind that. That's why it's called the dummy model. The dummy classifier model in Scikit-Learn completely ignores the input data. It doesn't really have a complex logic behind it. It actually has a strategy parameter which you can use to get different models. For example, if you set the strategy parameter to the most frequent, what it does is your dummy model is going to always make prediction to the most frequent class in your data. Or if you set it as to stratified, it's going to predict a random class based on the training data distribution. Or if you set it as uniform, it's going to predict a class using uniform distribution. Or if you set it to constant, you can ask it to make a prediction always to a constant label or constant class that you can specify which class to make prediction for. So no matter what the input is, the dummy classifier would always predict the constant class that you would specify. Dummy regressor model in Scikit-Learn. Similar to what we had for classification problems, which is a dummy model for classification problems, Scikit-Learn has a dummy model for regression problems, which is called a dummy regressor. Dummy regressors are used for regression problems. Similar to the dummy classification models, they have the parameter, the strategy parameter that you can set to get different models. For example, you can set it to mean, the average, which is going to use the model, set the model to make prediction as the average of the target variable in the training set. Or you can set it to median, which is going to make the model to make the prediction as the median of the target variable in your training set. Or for example, the quantile, you can set it to the strategy parameter to be quantized, so it would actually make the prediction as the quantiles of the target variable. For example, the first quantile, the second quartile, the third quartile, the 99% quartile, etc., etc. Or you can set it as constant, which would make the model to always predict a constant value that you provide. Let's see an example of an application of dummy classifier. So if your model's accuracy score is high, but it's actually close to that of dummy model, how should you interpret that? What does it mean? It could be a sign of ineffectiveness and erroneous or missing features in your data or in your model. Or it could be an indication of poor choice of parameters. For example, in SVC, if you're using the incorrect or inappropriate kernel function. Or it could be that you have large imbalance class in your data set. That means the majority of your data points are from one class and the other class are rare or sparse. In these scenarios, you should actually use other metrics than accuracy score. So let's see an example in Python. Always we're going to start with importing the libraries that we need. So we're going to import NumPy and Pandas. And from Matplotlib, we're going to import the pyplot and also accuracy score for evaluating the accuracy of our classification. And also we're going to import the train test split for splitting our data into training and test data set. We're going to work on the digits numbered, which is a data set in Scikit-Learn. And this is just basically the digit numbers. There are 10 classes, class 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so next we're going to load the digit data set here. So load digits, I'm going to put it in the variable data set. Then we're going to define our variables here. So X is our feature variable or independent variable, which is going to be dataset.data. And Y is our target variable, which is going to be basically whether it's class 0, class 1, class 2, etc., etc. So here I want to print out the size of each class. So how many, for example, how many data do we have? How many digits we have of class 0? How many digits we have class 1, 2, 3, etc., etc. So let's actually go ahead and run this. I'm going to run this here. All right. So as you see here, we have 178 data are from class 0, digit 0, 182 are class 1, 177 are class 2, and so on and so forth. So next we want to create actually an imbalanced data set. So what we're going to do is we're going to classify everything, every data classes, which have 10, into two classes. Class 1 and everything else is class 0. So if the digits, the number is not 1, it's going to be 0. So let's go ahead and do that. I'm going to define a target variable called y binary, because it's a binary classification problem, imbalanced. And that's going to be what I'm going to do. I'm going to make a copy of our data, the y variable that we define here. I'm going to make a copy of it. And next I'm going to specify the classes, the imbalanced data set. Okay. So what I'm going to say, okay, if it's not 1, put it as class 0. So that means y binary imbalanced if not equal to 1, then put it as the class 0. So let's go ahead and actually print out the original data both and the imbalanced data, or labels or classes. Let's go ahead with classes. Okay, so we're going to only print out the first 30 data points, and next we're going to do that for our imbalanced data set. Y binary imbalanced and 1 to 30. Right. So as you see here, our original class, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and again 1, 2, 3, 4. So we have all the 10 classes here. But our imbalanced dataset class, we only have class 1 and 0. So if it's 1, which is 1 here, is 1. If it's not 1, which is all of these are not 1, it's going to be 0. So this is how we create the imbalanced dataset. As you see here, the majority of classes are 0. You can actually also print out and compute the size of the imbalanced dataset, meaning that how many data points are class 0 and how many are class 1. Right, so let's go ahead and do that. So I'm going to print the size of the imbalanced dataset. So I'm going to use the NumPy bin counting. So it's going to be binomial counting. It's going to count the number of zeros and the number of ones, the two classes that we have. NP bin count. So I'm going to give it the y binary imbalance that we made. Okay. So as you see here, we have 1,615 data points of class 0, and we have only 182 class 1. So as you see here, is really imbalanced. It's more, a little bit more than 10%. So 10% of the data are class 1, more than 10%, and the rest, like about more than 80% are class 0. All right, so here we want to apply the machine learning on our imbalanced data set. And I have chosen to the SVC, the support vector machine, for classification here. So what we're going to do here is we're going to first split our data. So X train, X test, Y train, Y test. I'm going to use the train test split. I'm going to give it the X variable, the Y binary imbalance that we have created. And then I'm going to use the random state 0 here. So next I'm going to import the SVC. So from Scikit-Learn.svm import SVC. And I'm going to next introduce my algorithm. So my SVC, that's a copy of SVC. And I'm going to use the kernel function RBF. At the same line, we can actually train our algorithm to our training data set. So I'm going to use fit, X train, and Y train. And next, I'm going to make a prediction, Y predict. So I'm going to ask my model to make a prediction on the test data set. So let's go ahead and actually, now that we have made a prediction, let's go ahead and print out the accuracy score for our model. So I'm going to give it the Y target variable, the imbalanced data set here, which we have set it as Y test here. So that's Y test. And then our prediction is Y predict. So I'm going to put Y predict here. All right. So I'm going to run this. And as you see here, the accuracy score on test data on the imbalanced data sets is about 91%. And that sounds really high. That's really sounds really wonderful. What we want to see is, we want to see if this is because of our algorithm. Is our algorithm really good, or is it something else? So to do that, we're going to use the dummy classifier for what is called as sanity checks. So dummy classifier is just a classifier that makes prediction using simple rules. So here we're going to use the majority or the most frequent rule. And the dummy classifier is just going to be used as a baseline for comparison. All right, so let's first we need to import the classifier, the dummy classifier. So we're going to, from a Scikit-Learn dummy module, import dummy classifier. And then I'm going to my dummy model, and that's a copy of dummy classifier. So in the parentheses, we can set what strategy we want to use. I want to use the majority, or the most frequent. Most frequent. All right. So we need to train, quote unquote, train our algorithm. It's not basically train, it's just, it's going to find the most frequent class, and that's going to make the prediction based on that. So let's do that. Fit, and then I'm going to give it the X train and Y train. All right. Now let's go ahead and make a prediction. So Y dummy prediction. That's my dummy. Make a prediction on the X test data. So let's go ahead and print out the accuracy for our prediction. So first we need to give it the actual values, which is Y test, and the next is our prediction, which is Y dummy prediction. So the accuracy score for dummy variable with the majority or the most frequent base is about 90%, which is almost similar to what we have. This is about 91%, less than 91%, and this is about 90%. So as you see, it's close. So this means that our model is not really that good, because the dummy classifier performs as good as our model. To improve our model, we're going to use a different kernel function. So I'm going to define a new SVC function, and that's a copy of SVC with a new kernel. So the kernel function that I want to use, instead of RBF, I'm going to use the linear function. We can actually train our model on our data set on the same line. So let's go ahead and make a prediction now. All right, and now we can print out the accuracy score for our new model. So the accuracy score, the new accuracy score, is about 98%, which is very good. It is really high. So this is yes, compared to the 90% for the dummy model, this is still good. This is good.